copper waste is melted and then cooled to make new objects. You want to talk about kinetic particle theory, changes in movement and arrangement when a liquid cools to become a solid. So you have liquid going to solid. Okay, so what can we talk about? We can talk about a couple of things really. So what can I think about? Movement first. Okay, so movement first. The liquid particles can slide over each other. More space in between the particles. More disordered, or not so ordered. Okay, but when cooled to form a solid, the solid particles, meaning the solid copper particles now, will arrange in a regular ordered structure, which are closely packed, because they are solid, right? So they are closely packed and kind of touching each other. Yeah. Okay. In terms of the movement, in terms of the arrangement, I think there was mostly the, oh my god, I think I confused the arrangement and the movement. So there was movement, but when cooled, the solid particles should probably talk about their other thing first. Yeah, so it's very important not to get confused. I'm talking about movement here. So solid particles, the movement is just vibrate about their fixed position. A lot of it is just static, right? Your kinetic particle theory. And in terms of arrangement, I talk about more space. So liquid have more space in between the particles. Okay. Oops. Careful. No. I'm just moving things around to make things look a bit nicer, which you can't do in a real exam, obviously. All right. So liquid particles have more space in between. Liquid particles have more space in between the particles, whereas in the solid state, the particles are arranged in a regular close packing in the solid state. Yeah. Okay, next thing, when you warm solid carbon dioxide, so solid carbon dioxide is what we call dry ice. It's present in your different kind of fire extinguisher actually. So they call it dry powder fire extinguisher. It contains the solid carbon dioxide. Yeah, it goes directly into gas. This is called sublimation. So sublimation is going from solid to gas directly. They want you to use kinetic particle theory, movement and arrangement. So going from solid to gas, what happens? So you go from something where you can just vibrate about your fixed motion. So solid CO2 particles only vibrate about their fixed position. They are not free to move a lot, but then as they turn into gas, as they sublime, so meaning to say solid to gas, they vibrate much faster they move further apart. So they move further apart. What happened then is, as they move further apart, they are no longer in a really fixed position. So no longer in a fixed position or arrangement of particles. In this case, the particles are the molecules. So what happened is they go from you know how when you draw solids, they are always like very close contact to each other, and then when we talk about gas, we're talking about like them being so much further apart. In fact, you as if you don't get any interaction between the particles at all. So so there's the movement there. So they move further apart. In terms of the arrangement, you need to talk about going from here to here. So I don't want to write too much, but it's basically they move faster, they move further apart, more randomly, because gas move randomly, solids doesn't. So I guess that is the part on movement. As for the arrangement, you can compare solid versus gas very easily in terms of the close packing and the particles being a lot further apart. So I guess you can elaborate on those yourself based on what you learn from kinetic particle theory. Yeah. Okay. Food preservative there. Next bit, sulfur dioxide is stored in cylinders. When you open a cylinder, the liquid quickly changes to gas. So this is SO2 liquid goes to SO2 gas. So this is about change of state. What happens to movement? What happens to arrangement? In terms of movement, so you know how the liquid molecules, they how do I say this? They go from liquid to gas, right? So if you imagine they're like that. So it's not as closely packed as. So in the same space, they get so far out, they are no longer that closely because they get to move. They get to move a lot further because they have more energy now. Okay, so what happened is when SO2 turns from liquid to gas, so you must have supplied energy. Yeah, okay. The particles, in this case the SO2 molecules, gain energy and move further apart. Okay, so they get energy, they move further apart, and how do I say this? They gain energy, they move further apart, but you have to move they move further apart, no longer in close contact. So they are not closely packed, but they are in close contact with each other, but now they are spread far apart. I suppose there is arrangement rather than movement actually, so maybe I shouldn't specify. Anyway, but also when you think about it, how do they move further apart? So they also move faster as they changes, as the particle move apart. This gain in kinetic energy is a result in you going from, when you think about the change of state, you go from solid to liquid like that. So this is the change of state from solid to liquid. Here's solid, here is liquid. Actually, this bit here where the temperature remain constant, that's where the energy supplied is being used to break the force of attraction between the liquid molecules. So that's where they overcome the intermolecular forces between SO2 to go from liquid to gas. Okay, they actually have to gain kinetic energy here, and they gain kinetic energy as well in moving a lot faster after that. So I haven't really written down a lot here, but you can elaborate the idea essentially based on kinetic particle theory. Yeah. So this is not complete really. Okay, I'll leave it there.